Okay, so today we're going to be talking about Snell's Law, or the law of refraction. And so the first part to understanding Snell's Law is that we have to understand light. We know it travels in a wave. We can also define it as traveling as an array. And so, light, as it reflects off something or is emitted from something, it travels in this wave. And each of these wave fronts they're all traveling as one direction, so we can kind of condense this into traveling just as a single ray, which allows us to do different types of calculations and such. And the next part to understanding Snell's law is that this law of refraction is what refraction is. And so refraction is what happens to light when it changes and goes through different mediums or materials. So like in this example right here, we have this fish in water, and it has light being emitted off of it, or not emitted off it, reflected off of it. And then as it's traveling through the water, and then once it reaches and changes into the air, it has this refraction or change in angle. And that right there is because of light traveling at different speeds in the different materials. Light's going to be traveling a little slower in water than it is in air, which gives us that angle, those two angles, which allows us to see right here the two fish when there's actually only one. And we don't actually see where it is actually at. We kind of get this image that's either right here or right here when it's really right here. And so N right here describes as a constant of what is put into Snell's law to allow us to calculate certain angles and things. And so N, the constant, is equal to the speed of light over the velocity of light in a given substance. So now the speed of light is 3 times 10 to the 8th over something. And for example, we're just going to look at air. Air doesn't really restrict it. It's basically 3 times 10 to the 8 still, maybe a little slower, but which gives us n is equal to 1. In this table we see it's a little more than 1. And so we know that air doesn't really slow down light. But these other substances, that they're different n's, these ones slow down air quite a bit. For like example, diamond over here has a big one right here. And so with these given constants, we're allowed to solve for incident angles and how light bends and travels in different substances. So the example problem we have right here, it says find the index of refraction for medium 2, which is what n is. And so we're given medium 1, the first part is air. So we have light traveling through air, and it's going to hit and change as it goes into a different substance. So right here we have light traveling in at an angle of 30 degrees, the incident angle. It hits, and then it's going to be refracted and change angle as it goes into a different substance, which is 22 degrees. And so we can plug those into the equation. Also, we got to look for n for air. Remember, is 1 right here. So we have 1 sine 30 equal to, and 2 are unknown index of refraction, sine 22. And then we solve for that. We know, so we have sine 30 times 1 divided by the sine of 22. And what we get is n2 is 1.33. And we go to the table and we can figure out what that substance is. We find right here that it's water. And so in this next problem, what we have, light going from air to diamond. So we have, light coming from air out here, and then it's going to go into the diamond and be refracted. And so this one we're given, it's 30 degrees, incident angle, but we don't know the angle of refraction. So what we're solving for this time. And so we plug those into the equation. Remember, air, the index of fraction, right? For air is 1. Sine 30 equal 2. And then 2, we got to find that for diamond, is up here, 2.419 times the sine of our unknown angle. Now we can solve that. So sine 30 times 1 divided by 2.419 and the inverse sine, and we get the second angle, or the angle of refraction, is 11.93 degrees. And that basically is what Snell's law is in the law, or the law of refraction.